Structural analysis 2, chapter 9, force method. Let's solve another indeterminate beam example. So in this example, we want to calculate or determine reaction at B and moment at A. So we want to know what is the moment at A, MA is, and what is R B. So let's approach our problem. So definitely we are using superposition. We dissect our indeterminate one degree of indeterminate structure to two determinate structures. So this is a cantilever beam, the effect of a this kind of triangular loading. Observe this climb down to delta B distributed load plus the second part is a cantilever beam with just the effect of RB, which is a upward motion. So if we just add these two by the help of superposition, and we'll just know from the support condition delta B at y is equal to definitely 0. So these two cancel off each other, and then we can get the redundant the force of R reaction. So again, delta B to force plus delta V due to reaction should go 0, and that's the key point. Compatibility of deformation gives us this equation. Condition gives us support condition gives us the second one, and then if we just want to calculate the moment of our, for example, this cantilever with this triangular, if it's all the way to the end, that's double the intensity of our load is W. But if we cut our section from the other end by the length of arbitrary length of x, we can have mx, and then our intensity is x over L times W. Then the location is 1/3 of x, and if you just calculate the force, this is our force, and summation of moment about x goes 0 gives us this equation for moment, negative wx cubed over 6L, that's our moment equation. And then for virtual moment, the same part of the structure, we just cut it with the effect of no loading, but just 1 kilonewton downward to get delta at B. Just gives us small m is a negative x. So if we, with the help of virtual work method, we have real moment, we have virtual moment, small m, capital M, and then 1 times delta B by for the determinate structure of A to B without any redundant support is delta B by equal to WL to the first over 30 by other part of, so this part is WL to 4 over 30 by, that's this part, and the other part so is RBL cubed over 3EI, and these two based off our real structure should go 0 because there is no real movement at support, and so this downward motion of WL to the force over 30 EI to a triangular load at the cantilever beam plus RBL cubed I do just concentrated load at the end of the cantilever beam should go 0. So if you add them up together, it just the only unknown is RB. Just simply gives us RB is equal to 1/10 of WL. As soon as we have a RB, we can easily go for the summation of forces. The summation of force should goes to concentrated half of W. So it just simply gives RA is 4 over 10 or 2 over 5 WL. If you create a moment to get the unknown moment, it can easily can easily tells you force compared distributed load to concentrated load with length of L over 3 base just gives you moment. A is 1/15th of WL cubed squared. So that's our MA, which is 1 over 15 WL squared. With this kind of approach, you can easily get the reactions and unknown forces in determinate structure with force method. Thank you. We'll solve more problems, beams, trusses, and also frames with the help of force method.